Sir, shall we start?
Yes.
Yes, Abhishek will start.
Okay, sir. Thank you so much, sir. Good evening, guests and participants. I, Abhishek Arya, on behalf of Iei Tvlc, welcomes you all in Iei Tvlc Technical Lecture Series webinar. Tiruvallur Local Center is organizing technical lecture in a regular manner. Iei Tvlc Technical Lecture Series started from 19th of September 2017. 21 technical lecture conducted till date, and today we are here for 22nd technical lecture webinar titled as Fire Safety for Electrical Panels and Equipments. With these words, now I would like to request Dr. G. Sarvanan, Head Mechanical Division, IEI TVLC, to deliver the welcome address with introduction of Chief Guest. Welcome, sir.
Thank you, Engineer Abhishek Arya.
Thank you, sir.
At the outset, respected Chief Guest of the evening, Mr. Arun Kumar Balachandran, Director, Agni Controls, respected Chairman of Iei Tvlc Local Center, Dr. Jayarajan, Honorable Secretary, Dr. L. Ramesh, Joint Secretary, Dr. Jyoti Swarupan, Iei TVLC committee members, activity manager, faculty from colleges, industry partners, and student members. On behalf of Institution of Engineers, Tiruvallur Local Center, I extend a warm welcome to all for the 22nd Technical Lecture Series. So as Abhishek mentioned, this has been a quite long journey, and we are continuously ensuring that this kind of information is given to the students and faculty to get benefited. So today's topic is going to be on a vital area, fire safety and electrical panels and equipments. I hope and wish that we would take good insights from your lecture and apply the same in our area of work. I once again extend a warm welcome to one and all. Thank you. So I'm also given the responsibility of introducing the chief guest of the day, Mr. Arun Kumar Balachandran. Mr. Arun Kumar Balachandran is a graduate in Instrumentation and Control Engineering from Anna University. He is Director of Agni Controls, manufacturer and exporter of specialized fire protection equipments like flame detectors and gas suppression systems with trade name Flate T series, Balawat series, and D4 series. He has wide experience in R&D, design, engineering, testing, and commissioning of entire range of fire protection systems like gas suppression system, fire alarm system. His special focus is on industrial fire protection system and equipment fire protection. He is a member of CED 22 Firefighting Committee of Bureau of Indian Standards. Also, he is a member of various national and international fire protection bodies like Fire Security Association of India, FSAI, National Fire Protection Association of USA, NFPA, Institute of Security Management, IAM-SM, Institution of Fire Engineers, UK, Fire Protection Association of India. He is currently serving as the panel member in CIE Chennai for MSME panel and as finance chair for FSAL. He extended his service as faculty in many seminars related to fire protection. So with this introduction, I warmly welcome Mr. Arun Kumar Balachandran to deliver his lecture, and over to Abhishek Arya. Thank you.
Thank you so much, sir. So now I would like to request Dr. G. Jayarajan, Chairman, IEI TVLC, to deliver the felicitation address. Welcome, sir.
Good evening to one and all. Today's speaker, Engineer B. Arun Kumar Balachandran sir, and my Honorable Honorary Secretary Dr. L. Ramesh, Joint Secretary N.M. Jyoti Swarupan sir, and our committee member, distinguished member G. Saravanan sir, and my dear committee members. Very warm welcome to you for the 22nd lecture. So, the Institution of Engineers is popularly known as Institution IEI. It is providing non-formal engineering education, popularly known as AMIE in India, and this qualification is considered to be the equivalent to be a Bachelor of Engineering, and it is recognized by UPSC and all state and other government and many public and private sector organizations in India and abroad. So today's topic is fire and safety for electrical panels and equipments. Why we need this such a kind of topic is prevention is better than cure. Before coming to any ailment, we should take care of ourselves to protect our lives. So one part is financial loss we can manage, but nowhere human lives to be failed in our MRT engineers are facing such problems. They could not identify the line and other equipments, and they were met with accident also, fire accident in the substations. You can see in the newspapers also. It's very tragic. We are not bothered about the financial or any implications, but we should not lose even a single life. That is the motto of the fire safety. Whenever you go to any building or any structure, you can see a lot of fire holding will be in the walls, but nobody cares about it. When it comes to the emergency situation, then only we can able to know the importance of the equipment. Most of the things they have not maintained it. It has to be calibrated each and every year, or it has to be validated. It has to be the gas and other things has to be frequently changed. Then only it will work. Otherwise, by simply holding the fire equipment or system in our wall is nothing will serve. So it is an important topic, even though it is less known to us, but very important aspects we must know. Today's speaker, Arun Kumar, is having a director of Agni Controls. He's having vast experience in firefighting equipments manufacturers. I wish to tell one important message in this forum, even though it is not related to this topic. Our Arun Kumar's father is my close friend. He's our mentor for Lions Club of International 324A5 district. For more than 25 years, he was a leading lion. He has served so many projects. This year, he has taken up a project of district chairman for tree plantation. He has achieved, he has programmed his dream, he is having a dream of planting 1 lakh trees, Pasumai Chennai, in Chennai itself. So it's a very, people will think that it may not be achieved, but so far we have reached more than 10,000 saplings were planted within a short period of 15 to 20 days. July 1 is the target starting point. Within this 25 days, we have planted more than 10 lakh saplings. On behalf of Ashok Nagar Lions Club, we are planning to plant 500 saplings at near Pundi before August 15th. Like that, it's a great achievement. And I heard that even in the pandemic period, he has offered 100% salary for his total employees, even for not working. Actually, so many big companies are also following no wage, no work, no wage. But our Agni Controls has given 100% salary to all employees, and they given incentives also. I heard that. Hats off to you, Dr. Balachandran sir. And I wish to tell you that our Iei Tvlc rightly honored him in the last TLC award. We have given an award for him in the hands of Dr. Mailsamy Annadurai and Honorable Minister Pandiyarajan sir. So with these few words, and our speaker, the son of Dr. D. Balachandran, may also continue his social service in future and help the needy persons in future in following the footsteps of D. Balachandran sir. With these few words, I congratulate all my committee members, Dr. J. Balamurugan, D. Gogul, and G. Saravanan, Sanjil Kumar, and most of our committee members. Thank you very much for giving this wonderful opportunity. Thank you very much.
Thank you so much, sir. So it was a wonderful felicitation. And now I would like to request Mr. Arun Kumar Balachandran, Director, MS Agni Control, to enlighten the audience with his worthy words. Welcome, sir.
Good evening, friends. First and foremost, I should thank the Institute of Engineers, Tiruvallur Local Center for giving me this opportunity. Thank you very much, sir. And Dr. G. Jayarajan, sir, thank you very much for your kind words. Dr. G. Saravanan, sir, and Dr. Ramesh, sir, thank you very much for this opportunity. I will just share my screen and I will start my presentation now. So I think it's okay now. I'll just start sharing my screen now. So you are able to see my screen?
Yes, yes.
Okay. All right. Good evening, friends. My name is Arun Kumar Balachandran, and I'm director of the company called Agni Controls. So already much of this has been introduced by the speakers before me. I just have 6 slides about my company, after which I will go into the topic of fire safety on electrical panels. So already Jayaraj sir introduced my company, and this is Agni Controls is a family-owned company based in Chennai, started by my father Balachandran, and we manufacture very specific, specialized electronic products and few mechanical products. All these products are indigenous products manufactured here in India, and most of them are import substitute products. That is what I like to highlight here. So most of the products what we manufacture, it is all import substitute products what we manufacture. As informed, the company Agni Controls, we own different brand names. We have trademarks and registrations of different brand names. Balava is our brand name for suppression system, gas suppression systems. Flooded is our brand name for special application detectors like the flame, heat, spark detectors. DIFA is the brand name about which this entire presentation is about. It's specifically for electrical cabinets and for where you require automatic detect and small extinguishing kind of applications. So that's where our DIFA application brand comes in. And this entire presentation is about the DIFA brand. So if you see the slide, I have shown in the left side, you will find some electronic kind of products, and on the right side, you will find some mechanical kind of products. So as a company, we are very strong manufacturing capability of both complex and special electronics, detectors and sensors, as well as very complex mechanical and simple mechanical products. And together, it makes us a strong OEM, that is original equipment manufacturer for many machinery fire protection. So our main concentration is on machinery fire protection. So that is our main concentration. Just to show overview on some of the activity, what we do in our company. So we have a strong R&D division as a manufacturer. We have a special production area for our special application detectors, that's the electronic area, the mechanical assembling area, testing area, discharge facility areas, and we are very strict and stringent in our quality. which are set apart from many other companies in India. And many products we export to Europe and other countries. In total, we export to around 14 countries in the world. So when I talk of custom built OEM, so this is what I'm talking, like we give a custom built protection for gas turbines, steam turbine, paint booth area, dust collectors, machines. So this kind of big machines, but you can also find electrical cabinets. So today's presentation, what I'm going to cover, what I'm going to talk is only about the electrical cabinets. So that is what I'm going to talk about today. And with this, I will go right into the our presentation. So electrical fire. As Jairaj sir in his speech, he has already said, electrical fire is if you see in the newspaper, okay, you will find a lot of news about some fire accidents. And if you see very closely, 4 out of 5 news, you will find a word that the fire had started due to an electrical short circuit. Okay. This word would be very much prevalent in 4 out of the 5 news about a fire accident. So, and if you see, or what you see on the left, it is nothing but a small spark. But what you see on the right, you see a devastated fire, what a devastating fire can do to the instruments, and of course, it also affects the entire life safety aspect also. So our idea is to prevent before it spreads. That is, when an electrical fire occurs, it will occur only as a very small spark or a small flame. And our entire idea is to identify that small spark or the small flame and prevent it before it spreads into a bigger fire. So that is basically what we are going to see. Not just in India, but also if you take global level, that is worldwide level, any fire accident in the worldwide, 70 to 80% are fires which are caused by electrical equipments. It might be from the distribution panels, it might be from cable galleries, terminal boards, any electrical equipments start 70 to 80% of all the fires that is caused in worldwide. And as I said, this fire, it starts as a very small, but if it is unchecked, it immediately grows very fast and spreads very fast. And once it becomes very large, it is very not possible to contain this small electrical fire. So what is the traditional approach? So what we have been doing is typically if you see any substation or a main electrical panel where it is a distribution panel, okay, even in the apartments, okay, you will find main electrical distribution panels. So today you find a lot of portable manual fire extinguishers available at near the substations or near the electrical panels. That we need to thank to many associations, including the Fire and Security Association of India. The Fire and Security Association of India was started in the year 2002, and one of the main motive of that association was to create awareness to people with respect to fire and fire safety. And in the last decade or so, if you see, this use of fire extinguisher, manual fire extinguishers have taken a very huge step. And today, even in a very small shops, you will find small extinguishers. You will find small extinguishers even in some autos. Okay, and that is the kind of awareness that has been created. But what is the problem we have is that, as the name suggests, this is a manual fire extinguisher, which means it has to be operated by a human being. Okay, and it has its own limitation and disadvantages. Like since it's a human operated, it can the electrical fire cannot be monitored 24/7. Okay, and if you're not spotting the electrical fire in the initial stage, okay, only at the initial stage we can use a small extinguisher and extinguish the fire. Once that initial stage grows into a bigger spread and the fire starts to spread, then it is not possible to contain using the manual extinguishers. And more practical problem here is depends on the human who is going to use the extinguisher, because when fire happens, it is a panic mode, and we do not know that how each person will handle that kind of panic situation during the time of fire, and that can add to even fan off or spread the fire much more. So this has been the traditional approach of electrical fires in the last 20 years or more in the last 15 years. But we are going to talk about a new approach. So I say it's as a new approach, but this approach has been adopted for the last 10 years. It is being in use for the last 10 years. It is still growing in phase. That's why we still call it as a new approach in detection and extinguishing. Okay, what we are terming it as localize the fire. That means the fire, we are going to localize it. We are going to spot it where it is initiating, where the fire is going to occur. That is going to be the new approach in the fighting of, in the safety of the fighting of the electrical fires. Okay. Before I go into that, you should know about basics of fire. So what is a fire? How a fire happens? So that has to be understood. Once we know the basic, then we can go and handle the problems once you know the basics of the problem. So fire is nothing but a combination of three things. One, combustible material. Second, oxygen. Third, heat. What we call this we call it as a fire triangle. Okay. The reason why we call this as a fire triangle is because you all know that for any triangle to be formed, we need three lines, and all the three lines should be touching or joining each other. Then only a triangle will be formed. Similarly, for a fire to occur, we need to have a combustible material, and that has to be in touch with a heat link, and it has to be in touch with also an oxygen link. Only if all the three materials join together, fire can be formed. And also fire to sustain, we need to have all the three components, that is the combustible material, heat, oxygen. In an electrical panel, obviously we have oxygen, so that will be available. There will be a lot of wiring and cabling and some PVC channels and other components, so combustible material will also be available there. And of course heat, that is where the short circuit and overloading of fire panels and all the electrical panels comes into place. And when the heat occurs, then the fire starts in the electrical panels or any kind of panels. So once we understood the basic of how the fire has originated, so we can also easily put it off. So we can use carbon dioxide. Carbon dioxide is one of the most easily available and the most cheapest extinguishing agent. So I have taken the example of carbon dioxide in my presentation. So if you see when you introduce carbon dioxide into the fire, what it does, it removes two of the three links. The moment you introduce carbon dioxide gives you a cooling effect. So it would remove the heat. And carbon dioxide, it will also reduce the oxygen content from 21% to less than 14%. Okay. So carbon dioxide removes two links, and that's why it is a very good extinguishing agent than many other commonly available extinguishing agent. Okay, so now we understood the basics of fire, like how the fire has occurred and how we can extinguish the fire. So how we are going to use this into our electrical cabinet fire situation. So what we are going to do is the manual extinguisher, we are going to make it as a automatic kind of extinguisher. So that is the basic that is the basic idea behind this entire localizing the fire. So this DIFA is nothing but detect, that is detecting the fire, extinguishing the fire at origin, which means where the fire is starting, we need to detect that place, and that extinguishing the CO2 or any other extinguishing agent has to be applied on that particular place. So this is what we call as localize the fire. So it is detection, extinguishing fire at its origin place. So how we are going to do this? And this particular approach is now also is now being boosted by our new regulation also. So in India, we have a regulation called National Building Code. Okay, National Building Code or NBC is the building code which the entire Indian country follows for building different buildings. It can be a residential building, it can be an industrial building, it can be an any other occupancy kind of building, a mall, a commercial buildings. All this classification, it will come under the National Building Code. They will say how to build it and what are the safety aspects that has to be built in. So as per the new NBC 2016 regulation, this new approach of protecting the electrical panel is recommended for all electrical MV panel distribution panels and all lift panels. So the current regulation also supports this new approach in fighting the electrical fire. So what we are going to do is we are going to understand how this entire system is going to work. So in this system, we have two types. One is detect and discharge type, which is also called as a direct discharge. This is mainly for very small applications, very small enclosed applications. We use this method. Second one is a detect and actuate method, which is called indirect discharge. So this is typically used for larger volumes. So any big panels, which is a huge, having a volume of around 35 cubic meter or 40 cubic meter, then we have to go for a indirect discharge system. So what we are going to do? So in the DIFA, I said first is detect. So how we are going to detect the fire? In the manual extinguisher, there was no detection. So here we are going to detect it. How we are going to detect it? So we are going to use fire detection tube. It is nothing but a small polymer. It is a like this kind of red colored tube, but it is a very temperature sensitive tube. And what it will do is when a hotspot is there, when there is some heat developing, okay, and that heat comes to around 100 to 120 degrees centigrade, this tube will burst. Okay, so it is like a heat sensitive tube. We are going to use this particular tube inside our risk area. It can be electrical panel in our case. Okay, so what we do is this tube, we will pressurize it with carbon dioxide or nitrogen, N2. And when the temperature increases, the tube, it will burst at 100 to 120 degree centigrade. This I will come. You will understand more about this tube when I show the other animations and videos, because nothing is like seeing the videos. Then only you will be able to understand it better. So this tube is available in two colors. One is red and one is black. I am saying this because I have some photographs where I use some red tubes and I have also used some black tubes. So black tube is mainly for chemical and UV resistant, and also to an extent vibration resistant also. So this is for detection. And what we do is the direct method. Okay, in the direct method, we are installing the products to detect. That is nothing but the tube. We are going to install it, and the fire, it will be extinguished when there is an hotspot and the tube burst open. So detection is achieved by the fire detection tube, which runs in the protected area continuously. Extinguishing agent is discharged through the fire detection tube itself. That is, the detection tube will act as a detector as well as a nozzle also. It will discharge whatever content is there in the extinguishing cylinder. Okay. So this extinguishing agent can be carbon dioxide. If you want to be some environmentally friendly, then we can also use nitrogen gas. Nitrogen gas also can be used for extinguishing fire. Okay, so what I'm going to do is, this is a small animation to just understand better of the direct discharge method or the direct system. So you can consider this as an electrical panel. And what we are doing is, this is a manual extinguisher which we have converted to our DIFA system using a special valve. So this valve is a very special valve. It is not a normal extinguisher valve, it's a special valve. So we are connecting this, what you see here red color is the fire detection tube. Okay, so this fire detection tube, we are going to lay it inside the electrical cabinet. So we have laid like this inside the electrical cabinet, and what I am going to do now is I am opening this ball valve and I am pressurizing this entire fire detection tube with carbon dioxide. So now this system is in on condition. It is ready to fight any fire or any hotspot that has come, and this system is ready to operate. So now the detection tube is completely pressurized with CO2, and I am going to introduce a fire. So when I introduce a fire, there will be some heat generated, and here this heat, it will start to get the hotspot, and once the hotspot is there, then the detection tube will burst. Once the detection tube bursts, contents from the cylinder will go out through this detection tube. So here it is an opening. All the contents of the cylinder will come through this same detection tube, and it will fall on the same place where the fire had occurred. So this is what we call as localizing the fire. So if the fire had occurred in this place, then the nozzle would have burst here. If the fire had occurred in this place, then the tube would have burst here. If the fire has occurred here, then the tube will be bursting here. So in this method, we will use the detection tube as both as a detector, as well as once it detects and bursts, it will also be used as a nozzle. So this is the direct method, and because it is a direct method, we cannot use beyond certain cubic meter. And the next method is the indirect method. So indirect method is the detection and actuate method. Here what we are going to use is, we are going to use SS tubings or small pipings, and we are going to connect a real nozzle into the cabinets or the risk area. So I will just show the animation, which would be much easier to understand. So if you see in this application, it is the same kind of electrical panel, and we have laid the fire detection tube inside this electrical panel as a risk area. This is a different kind of valve. So in this valve, we are connecting a small SS tube or a small size pipe, which is a carbon CS pipe, which will be connected here, and we have connected it via a nozzle. Okay, so here again I am going to energize the system. So if you see, the ball valve is turning, so the entire deduction tube is now going to be pressurized. So now this entire fire deduction tube is pressurized with 20 bar carbon dioxide, and the system is ready for operation. I am going to introduce a fire again. So once I introduce a fire here, again this deduction tube will operate. Okay, this deduction tube will operate, and once this deduction tube operates, the contents from the cylinder will directly go through this tube or the pipe, and the entire content of the cylinder will be discharged from the nozzle. Okay, so the difference here is the contents of the cylinder will discharge from the nozzle, and if we have multiple nozzles, so through the multiple nozzles we can cover much larger space, and we can bring a inert kind of atmosphere for a larger volume. Okay, to understand it better, I will show you a small video. Okay, so whatever I have shown in the animation, I am going to show it in the form of a video. So you can imagine this as an electrical panel. Okay, this as the fire extinguisher with the a modified differ valve. Okay, and we have connected the red color fire deduction tube inside this cabinet. So you can view this entire fire deduction tube in the red color. Okay, so what we have placed here is we have placed 2 N-heptane fuel. Okay, so we are not going to just make a small electrical spark, we are going to create a bigger fire, and we are going to see the extinguishing capability of the system. So I'm going to play the video. Okay. Okay, and I've passed it. Okay, so we have just introduced 2 flames, both with N-heptane fuel. Okay, and if you see, within the next 5 seconds, the tube has burst and CO2 had released, and within the 5 seconds you would have find that entire flame has extinguished. Okay, and since it is in entire discharge mode, the carbon dioxide is still being discharged. Okay, so what happens here is, now as I said in my basics of fire, once we introduce carbon dioxide into the fire, it does 2 things. Number 1, it removes oxygen. Number 2, it gives a cooling effect. Okay, so in this cabinet, if you see, the oxygen content inside this cabinet would have fallen around 16% or 17%, and if you see here, the icing has also slightly formed, which means the temperature also has come down inside this cabinet. So what we are going to do is, we are trying to reignite, because the fuel is still there, the N-heptane fuel is still available inside. So we are trying to reignite, but since there is no atmosphere for reignition, the flame is not getting reignited. So for benefit of the viewers, I am just putting the video again. So the flame was introduced, and within the next 5 seconds, that the tube has burst and the entire flame has been extinguished, and the cabinet is now getting into a inert kind of atmosphere, so that no reignition occurs inside the panel. So this is kind of idea behind what the localized the fire is about. So the applications, I've just mentioned some of the application. It is not the full-fledged applications. So this can be, apart from electrical and electronic panels, we can use it in many other applications like UPS, server rooms, compressor, dust collectors, and other cable galleries. Even in electrical shafts, where we have a narrow electrical shaft where the cables are running, even there we can use this kind of solutions. Okay, and the advantages. So we saw the limitations of a manual extinguisher. Okay, so what we are trying to do is we are going to automate the manual extinguisher. So when we automate the manual extinguisher, one of the main thing that we require is we don't need to have electrical power, because once you have electrical power, then you need to have a battery backup. You have to ensure that the battery is always on, the electricity is always on for the system to operate. So this entire system operates on pneumatic. It doesn't require any electrical power, which means it's very easy to convert the manual extinguishing methods to automatic extinguishing methods without any electrical power. Since it is automatic, we don't need any manual intervention. It is very easy to install and maintain. In the next few slides, I am going to show you how easy it is to install and also do the maintenance. Refilling can be done locally because it is the agent is only carbon dioxide or nitrogen. The refilling can be done at any carbon dioxide filling stations or nitrogen filling station. Every city has multiple CO2 and nitrogen filling stations. Not much special tools are required, and the system can be integrated with hooters and any other fire alarm panels to give you audio visual signal, because you need to know if there is a fire and your system has extinguished, that has to be informed to the occupants or the owners. So we can integrate it with the use of a pressure switch to hooters, panels, or the centralized fire alarm panels. And we can also integrate it with the cylinder weighing system so that we can monitor the content of the cylinders. So these are the advantages of the DIFA system, especially the carbon dioxide one. And I am going to share some of the installation and maintenance procedure. It's a small one. It is not a detailed installation procedure. So what we are going to do is let's assume this as a panel, as an electrical panel or an electronic panel that needs to be protected. So we can clamp the cylinder either near the wall or even at the side of the panel itself, based on the size of the cylinder. So first step is to clamp the cylinder near to the panel to be protected. Second is run the detection tube in a zigzag manner or any manner which is available for you in the panel. So some areas we cannot use a zigzag manner. We have to go only on the perimeters of the panels. We can do that. Why we recommend zigzag is when you use a zigzag like this, okay, which means the kind of sensitivity is going to increase very much. The system will respond to very small fire or very small hotspot at any place. Instead of this zigzag, if you lay the tube only in the perimeter, that is only in the inner rectangle, then what happens is if there is a hotspot in the middle, it will take a very longer time for the heat to be generated and for the detection tube to detect it. So by the time, a lot of fire might start and spread, but the ultimate aim is to ensure the start of this fire is extinguished within this entire cabinet itself. We don't want this fire to spread to other areas, because this is an electrical panel or some other communication kind of panel. A lot of cables is going to come into this panel, and it is also going to communicate to other parts of the building. So you have a way to the fire has a way to spread through the cables to other places. So that is there, and that is the reason we recommend to install the tubes in a zigzag manner for a better sensitivity of the detection. Now the third step is connecting the tube to the valve. So all these connectors will be provided along with the system. So once you lay the tube, then the tube end has to be connected to the valve like this. And then we need to charge it. So in the animation I have shown you, I open the ball valve and then the detection tube gets charged. So like this, we have to open the ball valve very slowly for the CO2 to fill the detection tube, and it will fill roughly in the pressure of between 15 to 20 bar. So if you want the system to be in on condition, this valve should be in this position, which means it's an open condition discharge mode. The system is in on condition. For maintenance purpose, you want to do some kind of maintenance and you don't want the system to operate during that time, we can always close this ball valve, which means for maintenance mode, we are closing this valve and the system will not be in operation. So this is the small installation procedure, and this is about the operation. Most of the things we have already seen in the animation, like when the fire occurs, what will happen? The detection tube will actuate and the contents from the cylinder will come and extinguish the fire. So what we are going to do after that? Okay. So it is not that once the system is operated, the entire system has to be replaced. Okay, the entire tubing has to be replaced. It is not required like that. If you see here, this is exactly how when a detection tube get burst due to a hotspot or a fire. Okay, sorry. Okay, this is how the detection tube will look like when it bursts due to a contact in hotspot or a fire. Okay, so if you take an example of this kind of tubing, in this entire tube, if you see, only this spot is, only this particular spot is in a burst mode. All the other tube are very good in condition. So we don't need to change the entire tube length. What we can do is we can just cut this particular small piece, and like this, we can just cut it into a small piece, and then we can use the connecting connectors. There are tube jointing fittings which also will be supplied along with the systems. So that can be used, and a joint like this can be done. So which means typically you don't need to completely change the entire detection tube. Only the small part where the tube has burst, that part alone we can cut it and replace it with a connecting joints. Okay. Once you've done that, we need to also take the cylinder. Now the cylinder is empty. We need to take the cylinder for refilling. For that, close the valve, remove the detection tube from the valve, and then you take the cylinder for refilling. If it is carbon dioxide, refill it with CO2. If it is nitrogen, refill it with nitrogen. Once it comes back, again the same procedure, fix back the detection tube and slowly open the ball valve. So slowly open the ball valve, and the system will be again ready for use. Okay. So just to show you some examples, so these are some electrical panels. So each panel is being protected by a small DIFA systems, and here we have used a black color kind of tube. What you see on the left side is a hooter for annunciation. So, and also it has another connection to the centralized fire alarm panel for alarming the occupants. Okay, so here what you see here is the detection tube. So the fixing of detection tube, we can use multiple fixing options are available. So based on the equipment, based on the customer approval, we can use multiple fixing multiple fixtures for the detection tube. So again, you see this black color is the deduction tube that is running along the equipments. So here we have made the zigzag manner so that the nearest fire, if you see, most of the hotspot might occur in this area. So we have one more tubing underneath also. It is available. Okay. This is another photograph. Okay, so this is a oven control panel. So it's a very small panel. If you see the panel wise, there is no much hazard is available, but this panel is controlling a big oven. Okay, which means there is a lot of load here coming here, and as such, this particular panel is not very costly. Okay, but when a fire starts in this panel and it travels all the way to the oven, and from there it also can spread into other part of production. For that purpose, this particular customer has installed our system for protecting this panel. So here if you see this inside the panel, the deduction tube is running for protection of this panel. So very, very small panels also is now being protected using this kind of technology. Okay, so this is another video. This is another video from the customer side. So the first video what I've shown is from our company demonstration. So this is from the customer. So they have tested the product with the live equipments. So I'll just play. So here again, they made two separate fire. So if you see, they made two separate fires here. They were checking for multiple aspects, like they were having some channels here, live wires here. So they wanted to know how fast the system is working before the other critical equipments gets damaged or malfunction. So for that purpose, they were testing this. I'm just showing it again. So so if you see here, there was one puncturing that happened here, one puncturing happened here, and carbon dioxide, even if it comes to both areas, there are absolutely no problem because it's one single enclosure. So absolutely no problem, and it has extinguished the fire, and it is creating the inner atmosphere. Okay. So I've come to my conclusion kind of thing, and since many students are here, I thought this particular slide also I will add it for the benefits of the students. Not many engineers, not many engineering students or other students know about the fire and security profession as a security as a profession. So mostly students think of only IT or many big manufacturing kind of companies, but the fire, security and automation industry is also a very big industry. So this is for the benefit of the students to look at the fire, security and automation as a profession for your career. Okay, so I have given certain links. For example, the Fire and Security Association of India, that is the FSAI. So this association has student chapters across India, and they are providing hands-on experience on fire and security products. This particular association was started in Chennai. It was the founder president was my father, Mr. Balasan. He was the founder president of this association. So today, this association headquarters in Chennai is having chapters all over India, and we have a dedicated laboratory in Pune as of now. In Tamil Nadu, we have Kalasalingam University as one of the student chapter. and mostly we will be having one laboratory in Chennai, one in Madurai, and one in Coimbatore. That was the plan, where we could give students a hands-on experience on the fire products, security products, and automation products, so that there is a huge scope, huge potential of job opportunities inside India for in this particular profession, which if you have a hands-on experience, it will be very useful for you to go into the scenario. Sorry. The next one is the National Fire Service College from Nagpur. This is the central, it is directly under the Ministry of Home Affairs, and they give a Bachelor of Engineering for Fire Engineering. They also provide training to fire safety professionals. So if you are looking at fire safety profession as a profession, then you can approach them for some trainings. And then we have the Institute of Fire Engineers UK. The Institute of Fire Engineers UK conducts diploma courses in the fire and safety field, which are very well recognized across many countries. And again, for the Institute of Fire Engineers, we have a South Indian branch which is located in Chennai. So the exams can be written here in Chennai. You don't need to go elsewhere. You can write it here in Chennai. And then last, we have a National Fire Protection Association of USA. They also conduct certification courses, mostly which are online and which are recognized in many countries. So I've also given my email ID here. So if someone requires some kind of clarifications or some kind of information, you can always write to me, and I will guide you to the relevant person for those kind of things. Okay. So I will just open the floor for any questions with respect to my presentation. And thank you very much, sir, once again for giving this opportunity. And I'm open for any questions.
Abhishek? Abhishek?
Sir, we have received some online questions, so we'll take one by one, sir.
Yeah, sure, sure.
So first question is, what kind of sensors available in the fire detection cable?
Okay, this is nothing but a heat sensor. Okay, so when detecting a fire, we can detect the fire only using a smoke, heat, or flame. Okay, only these three characteristics are available. I should not say flame, I should be saying it as a light transmitting particles. Okay, so we can detect it using a smoke, heat, and light transmitting radiations. Okay, and this tube is like a heat, it is a heat sensor. So it is like nothing like, okay, you can imagine like this. Any material has its own physical properties. Okay, when you heat it beyond a limit, it will start to melt or it will start to deform. So this detection tube also is similar kind of tube. When it reaches 100 to 120 degrees centigrade, it is bursting. That is why we are keeping it in pressurized condition with nitrogen or carbon dioxide. So it is the tube itself is a kind of detector. It's a heat detector.
So thank you so much, sir. We'll take second question.
Yeah.
Are those special valves used in the DEFAO system of your patented product? I mean, do other companies also have a product using the same technology?
Worldwide, there are many companies which is having the same technology. So it is not a proprietary technology. There are many companies which is having the same technology. I didn't understand the first part of question. So that is Abhishek, can you repeat me the
Actually,
first?
first part of the question is, are those special valves used in the DEFAO system in your
Yeah. Okay. So it's only one question. So I think I have answered it. So it is not a proprietary kind of wall. It's a very specialized wall. There are many manufacturers of this kind of walls.
Sir, Arun Kumar, sir,
Yeah.
can you stop the screen sharing, sir, so that your face will come?
Yeah. Sure. Yeah. Right. Okay.
Now your face is come. Yes. Abhishek, what else?
Yes, sir. Yes, sir. So we will take the next question. What kind of fire system is suitable for UPS battery banks?
Okay. See, for battery banks, number one, we need to have a very fast detection system. So for detection system, we need to use a gas detector as well as a flame detector. So that gives the much faster detection. And for suppression, we can have two kind of thing. Like if it is a very small battery, you can go this kind of DIFA kind of very small system. If it's a huge battery, for UPS rooms, you have a very huge battery bank, then that entire room has to be protected. We can go with carbon dioxide, or if it is going to be a manned area, we cannot use carbon dioxide, we can go for inert kind of suppression. There are other chemical agents also available, but they are chemical agents. So the chemical is manufactured specifically for this purpose. So the choice is with the user. Mostly try to use environmentally friendly gases like nitrogen, or we can go for the cheapest, which is the carbon dioxide. Yeah, next question.
Thank you so much, sir. So, participant, whether you want to ask any queries, please ask. We have our Zoom participants.
Sir, Arun, sir,
Yes, sir.
I have one question, sir.
Yeah.
Sir, actually, in the video, you have shown that carbon dioxide is coming out and system is diffused.
Hmm.
The carbon, the balanced carbon will be in the panel itself.
Correct.
If anyone opens that,
Hmm.
will it not affect the person?
Okay.
The carbon
See,
dioxide will-
yeah. Okay. I will answer to that, sir. The amount of carbon dioxide. Yes, sir. I understood the question, so I'll answer it. The amount of carbon dioxide what we are going to use is directly proportionate to the volume of the cabinet. Okay. So once the door of the cabinet is opened, okay, fresh air will come in, and immediately the oxygen content will increase inside the cabinet. And if the CO2 comes out also, comparing to the volume of the room, this CO2 will be nothing. So the percentage of the room, the oxygen percentage of the room will remain as 20%, and it will not fall below 20%. So the gas what we have is very small when you compare it to the volume of the room. So it will not affect any, that kind of affection will not come. When you use huge large quantity, then we ourselves will not recommend to use it in a manned area. If it is an unmanned area, of course, we can use it for the carbon dioxide applications.
Yes, sir. Thank you, sir. Thank you.
So we will take our next question, sir.
Yeah.
Do the cylinder valve is automated because the spark can be ignited by any time, so that only valve is opened, the CO2 is released?
Can you explain? I mean, can you just repeat the question again?
Okay. So do the cylinder valve is automated because the spark can be ignited by any time. So if only valve is opened and CO2 is released.
Yeah. Okay. So if you see the ball valve should be always in open condition only. Okay. Only if it is in open condition, the system is in on condition. Okay. So the ball valve, what we have in the valve should be in on condition. We have that for maintenance purpose. So it should be always in on condition. Only then the contents from the cylinder will flow through the direction tube. If you close that ball valve, then automatically this content from this tube will not flow into the direction tube. So it is like a tap. So you open the tap and you have a kind of nozzle. Okay, you press the or you squeeze the like your hand shower. You take a hand shower, you press the hand shower, you will have water. Okay, and if you have a kind of isolation valve, you close the isolation valve. If you press the hand shower, you will not get water. It's the same kind of concept. So as long as the ball valve is open, the system will be operational.
Okay, thank you so much, sir. So next participant have asked, so can you advise me where we can use the only detection tube and where we can use the SS tube with nozzle? Any limitation is there for using a tube?
Okay. See, if I will answer the first part of question. So for the direct method, we can use it in all small panels. So when I say small panels, it is like up to 5 cubic meter, or we can go up to 10 cubic meter of volume. Okay. If you have multiple compartments, okay, and if you have a huge volume of around, like if you take for example a substation kind of panel, where the volume of, you will have 11 sections of panels or 23 sections of panels, and the entire volume, if you put together, it will come around 40 cubic meter or 45 cubic meter. There it is not possible to use a direct method. We have to use the SS tubing method in those kind of larger applications. Okay, and also in some kind of semi-open areas, we cannot use a direct method. We have to use a indirect method, that is using the SS tubes. And then for the direction tube, limitation is if you use long direction tubes, then the amount of CO2 or N2 in the cylinder cannot be used to pressurize the entire length of the direction tube, because the more this content of the cylinder is used in the pressurization, which means we are left with a very less amount of content for extinguishing. So as the direction tube is getting longer, we need to pressurize it externally using nitrogen. So that is the only limitation, but we can go for longer fire detection tube also. It is possible.
Thank you so much, sir. So we will take our next question.
Yeah.
Is there any mechanism that will stop the discharging of CO2 once the fire is put out?
Okay. In direct method, it is possible. You can always close the ball valve. Okay. So I have shown the ball valve. No, if you close that ball valve, it will stop. In indirect method, unfortunately, you cannot stop it because it is designed to do like that. So in indirect method, once the discharge has started, it will completely discharge the entire cylinder. Direct method, yes, you can stop it. You can close the ball valve and the discharge will stop.
Thank you so much, sir. So we take our next question. Tell some things about inert gas purging electrical panel in explosive area like refinery.
Can you repeat that question again, Abhishek?
Okay, sir. Tell some things about inert gas purging electrical panels in explosive areas like refinery.
Okay, again, see, even in
The
refinery.
is the PURGING, sir.
Yeah, I understood. Okay. Okay, again, in refinery, there are lot of fire protection prevention is a huge, and life safety is a huge topic, and this lecture we are focusing only on electrical cabinets. Even in refinery, we have substations and we have electrical panels. So there in electrical panels, we either in most of the substations, it is not the panel, they protect the entire substation itself using a total flooding. So that is the basic thing which refineries has been doing. So what they do is they use nitrogen as a purging element for bringing down the oxygen level to up to 16%. And since it's an inert gas, so no electrical, you very well know that nitrogen is present more than 70% in our atmosphere. So it is very inert in nature. It will not affect any of our electrical and electronic kind of components. And it is widely used in many places, especially in the control rooms where we have human presence. Next question, Abhishek. Abhishek.
Hello. Yeah, we'll take our question, sir.
Yeah.
Normally, for this type, butterfly valve will be required since fast opening is possible, sir. Is it, sir?
Okay, we cannot. This is a special kind of. You see, butterfly valve again. It's a bigger valve. Okay, so this is not a butterfly valve. This is a very specialized valve, and here the content of the pressure of the cylinder is 50 bar. So most of the butterfly valve or any other kind of valve is you have only up to PN16. That is, you can have only up to 16 bar, or you have to go for a high pressure valve, which is again very expensive. So that cannot be used here, and it is not similar kind of technology. It's a different technology here. I think Abhishek is not in line.
Abhishek?
I think Abhishek has left.
Arun sir?
Yeah, yes, sir.
Sir, what is the time period for changing any calibration has to be done frequently or any periodic? Some we have seen extinguisher validity period, it has to be calibrated.
Yeah. So, sir, yeah. So once in 6 months is the periodic maintenance time. Okay. That is, we need to check the contents. That's all. Okay. So with respect to the content, what we are more concerned is whether the content inside the cylinder, whether it's carbon dioxide or nitrogen, it is still the same or it has come down. Okay, that is what we are trying to do, and that has to be done once in 6 months' time. That too, we can always use an automatic kind of system. Like for carbon dioxide, we have something like a weighing kind of system. So if that system is being used, then you don't need to do it every 6 months. You will, once there is a leakage and there is a low weight, automatically that will be indicated to you as a low weight thing, which can be set as a low weight alarm. For nitrogen, we have pressure gauges. So we can use a pressure switch there, and we can indicate that if there is a low pressure, and that can be indicated to our communication. So once we automate that also, it is not necessary for us to do it every 6 months also. We can do it as a annual maintenance kind of thing. If we are not going for all those kind of things, we are going for a basic system, then we have to do it once in 6 months, like our extinguishers.
Okay.
Thank you so much, sir. One last question we will take, sir.
Yeah.
So, can this subsystem could connect to main fire panel for monitoring?
Yeah, of course it can be connected. We will have pressure switches, and from the pressure switch, we can have multiple connections to booters, or you can take the outputs to the centralized fire alarm panels, or even PLCs or DCS, SCADAs, anything you can take the. So we will provide one pressure switch From the pressure switch, we can multiply multiple contacts and can be taken into any kind of annunciation or control systems. It is very much possible.
Okay, sir. So thank you so much, sir. With this, we will like to thank you for the wonderful session. And now we will move ahead for vote of thanks.
Abhishek,
Yes,
Yeah.
sir.
before that, Abhishek,
Yes, sir. Yes, sir. Tell me, sir.
before, Arun sir, Balachandran sir has joined, sir. You are managing director.
Yeah, I think he is there.
Can you
He
ask?
is there.
Shall we ask
Yeah,
him?
yeah, he is there. He is there.
Sir, and sir, Balachandran sir. Sir, Balachandran sir.
Good evening.
Sir, can you speak, sir?
Okay, I have right from beginning. I'm just listening because you are especially asked me to join. So it was very useful for the students, and as Arun has explained, it is one of the very promising profession in this field. Many people will not know what is the strength and potential of this branch. Everybody knows fire protection mean only extinguishers, and now you know fire protection mean more than extinguishers. And it is one science itself. Is a fire engineering, fire science it is. So it has got a lot of huge potential, especially in India as well as overseas. And this will help most of the students. And it is already a link Arun has provided. So it will be very useful to them. Other professionals who are already using, this is the very unique, it has been initially, it has been totally imported, this technology. Around 20 years back, it has been mostly used in the Germany. In 1998 and 2000 period, it is mostly available only in the Germany, and detection tubes are made in only in Germany, and the walls are made in only Germany. Germany means Luxembourg. It is very next to the Germany is a Luxembourg in Europe. There, this technology, that time we went there and acquired this technology with them, and slowly whatever the technology we get it in abroad, that we bring into India and indigenous it. Now today it is available throughout India, and this technology and this kind of classes we have taken in many classes, and more than about 200 professionals are using this. They got the training and using it. It is easily available, and we made it very simple also, and still many people are now started manufacturing detection tubes, and also valves, of course, is a very special, and only few people are manufacturing or practicing it. So this is the one of the very special in electrical fire protection. As he rightly said, there is no power is needed. You can see the small shop, commercial shop, at the night 10 o'clock they shut down and they go, and only they get the alarm or fire alarm. Even you connect it into your mobile, but what you to see, you only get the information that fire is already started. And when you come back and open the shutter, you can see entire your shops are burned, which is already burned. It is like that things. But this system will immediately detect and start extinguishing, and also very cost effective, very simple to maintain. But this is what our Fire Protection Association also trying to teach the people. It's a very small money. You can save your entire shop and business place like that. So this is a very useful, and this is for one part. Another part is this meeting will help to the youngsters, and there is a lot of opportunity for them to learn also. This is for a student angle. And anyway, I thank you very much for your this opportunity and the good word about us. And we always try to do business and technology as well as the social activities. It is all needed now. So social, whether it is offering orphan care or tree plantation, this also parallelly has to go along with our other technical activities. Thank you very much, Ganesh, and others also.
Thank you for the wonderful speech, sir. Thank you, sir.
Thank you so much, sir. Yes, sir. Thank you so much, sir, for the wonderful speech, sir. And now I would like to request Engineer Hari Ram Chandar, Head Electronics and Telecommunication Division, Iei Tvlc, to deliver the vote of thanks. Please, sir.
Yes. A warm, grateful evening to our most valued Honorable Chief Guest, Mr. Arun Kumar Balachandran, and Management Committee, worthy members, my dear friends, and everyone gathered here. It's my privilege to propose a vote of thanks speech and acknowledge the contribution of those who worked really hard to make this technical lecture day happen. On behalf of my chapter, I extend a really hearty word of thanks to our chief guest, Mr. Arun Kumar Balachandran, who spread time from his busiest schedule to grace the occasion. Today, we had an opportunity to hear your thoughts, and this will surely be going to encourage us and in our future events. Your thoughts have enlightened our minds and have shown us a new path. My gratitude to all the speakers and other participants for this event. I am immensely thanks to our chairman Jayaraj sir and secretary Ramesh Kumar sir for his efforts towards anchoring of today. His own ideas and elegance of explanation of everything I need to mention my deepest sense of appreciation. I also extend thanks to all the committee members and other members of this chapter for their enormous cooperation within the organization of this technical lecture. Last but not least, a big thank to you, every one of you who made this lecture day memorable for us. We value you and every moment that you stay in this temple of learning. Thank you so much for all. Thanks.
Thank you very much for Abhishek Arya, also our activity manager, for coordinating
Thank
this
you,
event.
sir. Thank you so much, sir.
Thank you.
So one announcement for participant that feedback form is sent in comment box of our YouTube video, and participant can fill that feedback form and claim their e-certificate. So certificate will be provided after filling the feedback form. So now we will close the session, sir.
Abhishek, can you play the video clipping? 1 minute. Is it possible?
Okay, sir. We'll do on next time, sir. We'll play the things.
Okay, thank you.
Okay, sir.
Thank you very much, sir. Thank you,
Thank you,
Ananda.
sir. Thank you.
Thank you.